So question number 7. An electronics hobbyist is building a radio which requires 150 ohm in her circuit, but she has only 220, 79 and 92 ohm resistors available. How can she connect the available resistors to get the desired value of resistance? Okay. So what is given is, see, the resistors available with her are R1 is equal to 220 ohm, R2 is equal to 79 ohm, and R3 is equal to 92 ohm. Okay, but what is required is 150 ohm. So what we do is, normally if we have 3 resistors but our requirement is different, you have to use the available resistors in different combinations, could be either series or parallel or a combination of both series and parallel, so that you get the required resistance of 150 ohm. Okay, so first you start with all the resistors are connected in series, but we know that if the resistors are connected in series, the equivalent resistance is larger than the maximum of the individual resistances. So when resistances are connected in series, R equivalent in series is equal to R1 plus R2 plus R3, okay, which is 220 plus 79 plus 92, which comes around 391 ohms, which is not what she wants. Then you try connecting all the resistances in parallel. Okay, so we know that when the resistances are connected in parallel, the equivalent resistance is smaller than the smallest of the individual resistances. The smallest of the individual resistance is 79. So when these resistances are connected in parallel, the equivalent resistance is going to be less than 79, which is also not the required value. Okay, but let us try. In parallel connection, 1 by R equivalence is equal to 1 by R1 plus 1 by R2 plus 1 by R3, which is 1 by 220 plus 1 by 79 plus 1 by 92, okay, which comes around 0.028. 1 by R equivalence is 0.028. R equivalence in parallel connection comes around 35.62 ohms. Again, it is not what she wants. Okay, R equivalence when all the resistances are connected in series was 391, so that is of no use. So we are not going to connect all in series, not even all in parallel. So we have different combinations now. What I am going to do is connect R1, R2 in parallel and R3 in series. Okay, fourth option is going to be R2, R3 in parallel and R1 in series. Okay, or what you can do is, fifth option, R1, R3 in parallel and R2 in series. Okay, so we'll start with third one. Let this be R1 and R2. These are connected in parallel and this is connected in series. Okay, this is 220 ohms, this is 79 ohms and this is 92 ohms. So these two, R1 and R2, this is R3. So I'm going to find an equivalent resistance. This is R12 parallel, this is R3. Then I'm going to find an equivalent resistance where R1, 2, 3 are in series. Okay, so for parallel configuration, of R1 and R2. 1 by R equivalence is equal to 1 by 220 plus 1 by 79. So this comes around 0.0172. So R equivalence is 58.12. This is R equivalence of 1 and 2 in parallel. Then R equivalence of 1, 2 and 3 is equal to 58.12 plus 92. Okay, these two are series, no? So directly we can add these two. So it comes around 150. R equivalence is equal to 150 ohm. So what we have done is, there is a parallel combination of 220 and 79. So the answer is given as parallel combination of 220 and 79, and this combination is in series with 92. So what you get is, the equivalence is 150 ohms. This is 58.12 ohm and this is 92 ohm. Okay, that's it.